Welcome to Train Signal. I'm Ross Bagurtis, and in this video we're going to be diving into router configuration. Now this is the really cool part of data networking when we get to actually get on the router and start configuring and playing with it. The problem is that the learning curve to this can be a little intimidating at first, but what we're going to do is go through step by step, make sure you understand exactly how to get on the router and put a base configuration on it so you can actually pass traffic through it. So before we get into that though, we have to take a look at the router that we're going to be configuring and discuss the interfaces on it and how we connect to it and whatnot. So here in this image, I have a Cisco 1841 router. This is the router that I'm going to be using to demonstrate all of the router configuration and routing protocols and networking throughout this video series. Now, unfortunately, the Cisco 1841 is no longer made, but it is an extremely popular router in industry. It is in many small businesses, and in the large business enterprise world, they use them there as well for routers at remote sites. So if you have a large organization and you may have a remote site in a rural area that's far away, chances are you would use a device like this in order to connect that rural site up to the main site of your network. Let's talk about a couple things here. First, let's talk about the cables. So the cabling we need to connect our router together is going to be varied based on our configuration. But essentially here, we're going to need a rollover cable. Now, a rollover cable is a cable used to configure a Cisco router. It has a very specialized pin setup on it so that we can use it to connect from the router to a serial port of a PC in order to put that base configuration on the router itself. Second, we're going to need Cat5 or Cat6 cables. These are just standard Ethernet cables that we're going to use to connect our router to either a PC or a switch. And we may need a Cat5 crossover cable or a Cat5 straight through cable. It could be one or the other. This USB to serial adapter or serial to USB adapter, what that is it's a mechanism to put a serial port or an RS-232 port on your laptop, which nowadays typically do not come with serial ports. Now, what the heck is a serial port? Well, the serial port is an RS-232 connector. It's a very old school way of doing data networking. As a matter of fact, if you ever used a modem, modems use serial communication to transfer information. So if you had that dial-up modem in the mid-90s, maybe even in 2000, geez, my grandma was using a dial-up modem all the way up until 2007 or so. Those dial-up modems all used serial communication to connect from the modem itself to the PC, and then from the modem out to the telephone network into somebody else's modem. That was all serial-based communication. Well, nowadays we don't use modems. Most of our devices that we buy, PCs, laptops, and whatnot, do not come with a serial port. So we have to actually add that serial port in order to get the functionality on our PC so that we can configure the router, or at least put that base configuration on the router. Now that last cable there is the V.35 cable. This is used for connections that are like T1 connections, T3 connections. This V.35 cable is an old school serial cable for high-speed serial networks. When do we use that cable? Well, if we have a high-speed serial network like a T1, T1s operate at 1.5 megabits per second. Now, chances are if you live in a larger city in the United States or Europe or any other larger country that has excellent access to internet, chances are a T1 at 1.5 megabits per second is going to be ridiculously slow compared to the other technologies out there like cable modem and DSL. So in modern world, we don't actually use that V.35 cable very often. As a matter of fact, if we do need a T1 connection, oftentimes it comes in to our facility with a cable that looks just like this Cat5 cable, except it's going to be called a DS1 cable instead of Cat5. So we have lots of options here for our serial communications. The reality is that In order to study for the CCNA, you have to understand what these V.35 cables are. In order to operate networks in the real world, we don't use those serial connections as much anymore. Most of our connections are going to be using this Cat5, Cat6 type cable and Ethernet as our protocol. Okay, so let's dive into the router then. So on the router, let's start at the rightmost side here. We have the power plug, we have the power switch, and then we have this slot 0 and slot 1. Now the slot 0 and slot 1, these are these module slots. And what I have in there right now is are these cards. It's called a 1 DSU-T1. And what that is, it's a serial port that allows us to connect two routers together using something like a T1 connection. And I actually have two of those network interface cards, these serial network interface cards, plugged into slot 0 on the right-hand side and slot 1 on the left-hand side. Now, these serial cards that I have plugged in here are not the only modules we can plug in there. There's a variety of modules. We can plug in extra Ethernet ports. We can put a little switch in there. There's some security modules we can add. These slot 0 and slot 1 are modular. They're meant for lots of different things. I just happen to have mine configured with two serial ports because that's the primary focus of CCNA study. Now, in the middle here, there are some built-in ports. And the built-in ports, there's usually 4 of them, especially on the 1841. And the 2 on the left are going to be for transferring actual data. And those are fast Ethernet ports. Fast Ethernet operates at a maximum of 100 megabits per second. So if we look at the hierarchy actually of the terminology there, Ethernet is a 10 megabit per second technology. Fast Ethernet is 100 megabits per second. And gigabit Ethernet is 1,000 megabits per second. And it goes up from there. And we refer to them accordingly. So whenever we refer to Ethernet on a Cisco router, we're talking about a 10 meg connection. Whenever we're talking about fast Ethernet, we're talking about a 100 meg connection, and gigabit Ethernet or gig Ethernet or even gig E, we're talking about 1,000 megabits per second. On this 1841, we have 2 fast Ethernet ports. The fast Ethernet port on the bottom is labeled fast Ethernet 0/0, and the fast Ethernet port on the top is labeled fast Ethernet 0/1. These use these Cat5 or Cat6 cables with an RJ45 end. Right next to it, you see 2 more ports. And those 2 ports look nearly identical to the 2 ports on the left. Well, these 2 ports on the right are the console and aux port. Those are actually not fast Ethernet ports, even though they have the same kind of connector. They are not fast Ethernet ports. So console and aux are not fast Ethernet. A lot of newbies, when they're working with the Cisco router, they'll actually plug their fast Ethernet cable into the console port and try to pass data across it and wonder why it's not working. And the big reason there, once again, is the console port is not a fast Ethernet port. What the console and aux ports are here are they are used for configuration. And on a Cisco router, we use serial communication in order to communicate with the router. Well, but wait a minute, Ross. You just told me we use serial communication for the T1s. Yes, this is true. We use a serial communication to pass data, actual routed data, with IP addresses and stuff in it. And we use that with these serial interfaces, these serial network interface cards. They're also called WAN interface cards, or WICs, W-I-C. These cards actually do use serial communication, and the neat thing about them is that they can pass traffic at the network layer of the OSI model. Well, what that means is that they can actually pass traffic that has an IP address in it. The console and the aux port cannot do that. The console and the aux port can only pass data basically at the data link layer, and it's meant in order to put a base configuration on our device. So these Cisco routers, when they come out of the box, they are blank. There's a default configuration on it, but the default configuration is extremely minimal and does not let you operate the router fresh and clean out of the box. If you pull that router out of the box, plug cables into it, and turn it on, nothing will happen because all of the interfaces are shut off by default, except for the console and aux port, which allow you to connect a rollover cable to it, plug that into the serial port of your PC or your serial to USB adapter, and actually use that then to put the base configuration on your device. Why the aux port then? We have the aux port because remember earlier I told you that this device may be sitting in a rural office that may be 150 miles away from your desk. Well, we use the aux port there so that we can actually hook up a modem to the aux port and plug it into a telephone line. That way, if there's some issue where the network goes down at the site where this is located, instead of having me to drive in my car, drive 150 miles to the site, I don't have to do that. I can sit at my desk, dial in with a modem. I realize modems are antiquated, but we actually still kind of use them in data networking for backup support. We'll actually plug that modem right into the aux port of the router. Then we can dial in and check out what's happening with that router should there be a network interruption and we cannot reach the router via its IP address. So this gives us an out-of-band mechanism to control the router, which is really outstanding. Now, the other reason we'd use that aux port and the modem dial-up is sometimes we're configuring stuff on that router and you can actually do something called cutting your arm off, which means that you shut the network connection down between your PC and the router. When you shut the network connection down between the two devices, you can no longer configure the device. So you have to have some other mechanism to get into the router and configure it. So the console and aux ports are used for configuration. Our fast Ethernet ports are used to transfer data. That's what we're going to hook up to either a switch or a switch and then a PC. So we're going to have basically network devices hanging off of those fast Ethernet ports. And then our WAN interface cards here, the serial ports, these two cards in here, we're going to use those to connect to other routers.